Welcome to Linked Data Engineering, Lecture 2, RDF and RDFs. This is the last part of the lecture, and we have been talking about RDF, which is the basic building block for information exchange with linked data and in the semantic web. Now we are going to talk about how RDF can be put into the web, into the HTML page. So we are talking about RDFa, RDF, and the web. The topic we are talking now is, of course, related to RDF, and as this is kind of a special serialization of the RDF format, it is in the semantic web layer cake below the RDF layer. You see here among XML and Turtle also RDFa and microformats, which are the topics we are talking about today and which are kind of serialization formats of RDF. Okay, so how do I put semantic annotation into the web? In principle, you have three possibilities. You can use, for example, so-called domain-specific microformats. Microformats are around for quite a while, for more than 10 years. We will see what are the drawbacks and why you should use the more generic RDFa solution where you put RDF information into HTML attributes. And of course, you have another possibility which works about in the same way, which is called HTML5 microdata. Microdata is quite similar to microformats. You have a bit more flexibility, but you also here rely on fixed vocabularies which have to be agreed upon in the community. So you cannot simply define your own microdata and everybody will understand it. So this might be kind of a problem, but we will come back to that later. The most prominent microdata vocabulary, you've probably heard of it, is schema.org. Okay, let's start with a microformat. So microformat emerged about 2005, and the problem was people wanted to put structured data into HTML pages. Simply for one reason, to get data out of HTML pages, usually you had to write a parser. And this screen scraper and parser, they had to get, for example, address data out of a page. But the problem was everybody was formatting address data in a complete different way. So there should be a way to put structured data somewhere into the HTML page. And one way was to use this HTML or XHTML markup, and so therefore they came up with the idea to use a specific or some of the specific available attributes within the HTML text, for example the class attribute, and then they put to the class attribute, for example, some specific keyword which belonged to a specific vocabulary, a microformat vocabulary. And then, for example, if you So usually you use the HTML text to format things, to structure things in your HTML document. So the point is you do not always have the right tag available to put some additional information into it. So what you are doing is using tags which are usually, let's say, not really used for formatting, but only for some limited structuring purposes. So only, let's say, abstractual structuring, like the span or the div tag, that are used to define sections or used to define paragraphs or something like that within a document. But they do not have any functionality concerning formatting. You can use these tags, then put the class attribute in it, use then as a value for the class attribute the name of a keyword which belongs to a microformat, and then an external parser will be able to extract exactly this structured data, and also it will understand the data because you are using a specific keyword that somebody has agreed upon. Okay, let's have a look at an example. Here we have an HTML marked up with a specific microformat which is called HCARD, which stands for address data. Here you see, for example, the div tag, and here we have a keyword vcard, which means now comes the definition of address data. And then you see several keywords like FN for the first name, title, then we have org for the organization, ADR stands for address, and then comes address data like the street address, postal code, and stuff like that. And then comes the telephone number and more. So this is an example for a vcard microformat that can put into the web page, and what you see in the web page is only what you see here within the text as the character data, so the content of the address. But the parser is able to detect and recognize the keywords that you use, and if the parser knows that you are using the HCART microformat vocabulary, it will be rather easy to interpret the content correctly and to read this structured data. I mean, the drawback of this, of course, is obvious. So let's first look at the positive side. Microformats can easily be transcoded to RDF. This is not a big deal. So you can use, for example, these XML style sheet transitions. So this is absolutely no problem. But the point is, a vocabulary, before it can be used commonly, must be consolidated by the community. This might take a long time. There can be lots of discussions until a new format really puts up and can be used. So this is, let's say, a more or less complex and tedious task. So you cannot simply invent a new format and use it. So this is kind of complicated. Moreover, if you are using in the same document more than one microformat vocabulary, you mix up things quite easily, and also the complexity increases rapidly in which you're using these microformats. Another thing is, of course, you are using already existing attributes from HTML, and there might be, of course, a clash or a conflict because there's a problem in interpretation. Is it a microformat or is it really something which is related to HTML? So conflicts might arise if you are using already existing attributes. A solution would be to define new attributes. So, how do we put RDF in HTML? And what we are using, of course, is also attributes. But the solution the community had come up with is RDFa. And in RDFa, they, of course, first they have reused existing HTML attributes. Now they are defining new attributes to avoiding these kind of clashes. So the first issue or the first version of RDFa, which is RDFa in HTML attributes, was issued in 2008, and it has been refined in 2012 to RDFa 1.1. And we will talk about RDFa Lite 1.1 because this is completely sufficient for our purposes. RDFa 1.1 offers a bit more flexibility, but for us, RDFa Lite 1.1 is completely sufficient. So, which kind of attributes are used? For example, href and source, they are usually used in the same sense as in HTML to denote a URI. For example, you know the anchor tag A. There, href is used as a reference hyperlink, and in the same way, of course, it is used also in RDFa. And you know maybe the image attribute in HTML. In the image attribute, you can give the URI of an image with the help of the source src attribute, and in the same way, the source attribute is also used in RDFa. Therefore, you avoid here clashes. And for the other things, new attributes have been introduced, like the vocabulary attribute, the type of attribute, property attribute, resource attribute, and the prefix attribute. And I mean, simply look at the names. You might already guess in which way they are used. We will look at an example, then it will be much more easier to understand. So, we start with RDFa Lite 1.1. We want to put some structured data into our web page, and you see here we are defining a paragraph in HTML. So in this paragraph there's some character data. There is my name is Harald Sack, and you can give me a ring via, and then comes a phone number. Of course, it's an imaginary phone number, so don't try to dial this. What we can do first is we can say, okay, we want to use some RDFa data, but for that we want to first make sure to use a specific RDFa vocabulary. So it means a place where this RDFa that we are using is somewhere defined. And we are, for example, using an already existing vocabulary, which is the FOV, the friend of a friend vocabulary. You will see this more often in the course of the lecture. FOV is a very prominent vocabulary which is used to express, for example, relationships in social networks, to enable to include structured data about persons, addresses, organizations, and stuff like that. So we are using exactly this kind of namespace here. It's a namespace, the FOV namespace, where all the properties, the classes that we are using here are defined. So this is the vocabulary that we are using. Okay, let's continue. We want to talk about a person, so we give a class definition. So all the data that comes here refers to a class, which is type of person. And person here comes from the vocabulary that is defined above, from the FOV vocabulary. So it's a class of the FOV vocabulary. So all the rest that comes refers to a person. What's next? Next, we are going to use the properties that are available here. So one, or the first that I see here is my name is Harald Sack, and then of course FOV offers the possibility to define a name, so it has a property which is called name, and then simply I use this property, I define a span HTML tag with property equals, and then the value is name, and then within this tag, within the span tag, I write simply character data, and then I write the string Harald Sack, which then is the name or the literal, which is assigned to the property name of this entire construct. So the name is Harald Sack. Quite easy. I do exactly the same thing with the phone. You see here, I define another span tag with the attribute property, and I give it the value phone, and then as character data, I provide the phone number. Next thing, I also want to provide an image, therefore I use the HTML image tag. I also give it the property image, because image is a property that is defined in the FOV namespace, in the FOV vocabulary. And then, as you see here, I simply denote the source of the image, like you do this in HTML. So you give the URI where the image can be found. And also, if a browser then is displaying this image is simply displayed because IMG image, it's an image tag, and you have a source which points to a picture. Therefore, this picture here, if it's accessible, if it's there, it will be displayed. This was easy, wasn't it? We're not quite done. We can do much more. So what we have defined here is something like a blank note, which is of type person and so on and so on. But what I can do is, of course, I can really define, of course, a resource here. Therefore, I have the attribute resource. So I use the attribute simply as a second attribute in my paragraph tag and say, okay, here I'm talking about me, myself, something which is called Harald. And the base URI that you have here usually refers to the URI of the web page we are talking about. And therefore, in this web page, which possibly contains information about me, I define a resource which is called Harald, and all this resource is the subject of all the properties that are defined below. Also quite easy, isn't it? So therefore, my name will be Harald Sack, my phone number is given here, and then there comes also an image of me. So far, so good. Possibly, I want to use also another vocabulary, another namespace. Like you are used to do this in Turtle, you can define a prefix to define another namespace. And here, again, I use it as another attribute within my paragraph tag. Right in the beginning, I define a prefix and say OV, stands for openvocabulary.org/terms. And this then defines the prefix of the next vocabulary that I use. And you see then here in the very last line within the paragraph definition, I define another span tag with a property where I used a keyword or a property which is defined here in open vocabulary within the namespace that I have referred to via OV:. And then I have property equals and then the value OV: preferred beverage. It works perfectly in the same way like in Turtle. So OV: is substituted by the URI or URL prefix that you have defined above. And then I write here that my preferred beverage is green tea. So I can use any vocabulary I like. I have to define only prefixes for that. And therefore, they cannot be mixed up. So this is also quite simple. Sometimes the content that is displayed in the HTML file should be different from the content that is read by the machine if the RDF data is extracted. For example, if you are dealing with things like here, for example, a date, you want to give the date another format than the traditional format or the format that is somehow fixed. So what you do is, here I define, for example, a property created. And the property created denotes simply that this part of the document has been created at a specific time. And then what is displayed in the document is 28.10.2012. But what will be extracted if RDF is extracted from the web page, this can be alternatively defined in another attribute, which is called content. And in the content, you can give a literal in a complete different formatting. So RDF takes not then the character data, but the literal that has been defined in content. So you see here, this is the presentation of the HTML file, but this is the content that will be extracted by the RDFa parser that reads RDFa and extracts RDFa from your HTML file. Okay, what else can I do? For example, if I read a literal, literals can be typed. And for this, there is a new keyword that can be used, a new attribute, and this is simply the data type attribute. And then I say data type equals, and the value of the data type then is one of all these XML schema data types that we have learned of in the RDFa syntax. So for example, here I can use a year, or a global year. This is a date-based identifier which is available in XML schema. And then I say this 2012 should be interpreted as a year in a date. So far, so good. In general, you distinguish two different sorts of RDF triples that you can put, of course, into an HTML file. We know that we have triples where the resource is an object, so another URI, and we have triples where a literal is the object. So two different things. First, let's have a look at the literal. So the object is a literal. This is the first row, the first line that you see here, and it's the blue line. So the subject here, for example, will be expressed as resource. There is an alternative to use another keyword, which is about. This is from RDFa 1.0, so it's the old version. It's only listed here for compatibility. You should use resource, because resource is newly defined. About did already exist and might lead to conflicts. Then property, there will be used the keyword or the attribute property. And as object, you use either the past character data that stands within or enclosed of the two tags, or you use the content attribute where you can give an alternative formatting, alternative representation of the character that should be read by the RDFa parser. Likewise, if the object is a resource, means the object is a URI, you use as a subject resource or about, and as a property you use property. And also you can use REL, which stands for relation, but this is also RDFa 1.0, so the old version. And then as an object, you can link the object either with the help of the href attribute or the resource attribute. So you have these two possibilities to link everything together. And you see it's quite easy to put RDF data into HTML. The interesting thing is you don't notice it if you see it in the browser. But on the other hand, if a program is going to pass the HTML file, it is able to find exactly these attributes and then to extract all the RDF data that is related to the document in an automated way. That's quite nice, isn't it? Okay. Finally, another possibility that I also want to introduce to you is the usage of HTML5 microdata. This is kind of an extension of microformats, of the existing microformats, and addresses especially its shortcomings. And possibly you have heard of the most prominent microdata vocabulary, which is schema.org, and which is heavily used by all the search engines. What does microdata do? Simply it annotates the domain object model with so-called scoped name-value pairs for custom vocabularies. So in the same way like microformats, it does this. But the main difference is there are lots of vocabularies available, and new global attributes have been defined, these microdata global attributes. So there can also be no mix-up because there are new attributes that can be used. Of course, these are different attributes, but from the way they work, they are quite similar to the attributes that have been defined for RDFa. So we have item scope to create a resource. We have item type to say what kind of vocabulary is applied. We have item ID to identify resources. We have item prop for properties. And we have item ref for references to other resources. And there is lots of macrodata vocabularies for persons, for events, for organizations, products, reviews, and so on and so on. And the nice thing is all of this is, of course, extensible. But again, if you apply that a new microdata vocabulary might be used, this is also a problem of agreement, because if it's used, then usually the people who are using it, their programs, they must use and understand it and process it in exactly the same way. And therefore, there must be some agreement, some written agreement, what is the meaning of all these new vocabularies. And this kind of meaning usually is written down in natural language, which in the end might lead to ambiguities and also to misinterpretation. The benefit of RDF and RDFa is in RDF you have a fixed formal semantics. So it's machine readable and machine interpretable. In the end, the machine understands the data because RDF and RDFs, and later on also OWL, we will learn this in the next lecture, they are based on a formal logic which can be interpreted correctly by the machine. Okay, let's have a look at an example. Again, we have here an HTML file. We define a new item, so with item scope, a new resource, and we say this resource is of type person. And of course, we give the entire URI of this person vocabulary that we are using here. Then there come some properties, like in our other example, the name, for example, is John Doe. Then we have a title, we have an affiliation, we have a nickname, and so on and so on. So these are all properties which are defined in the person vocabulary. Just read it and try it out. We have also prepared the file here, so if you click on the link that you see here, a browser will pop up, and of course the HTML page will be shown. In the HTML page in the browser, of course you don't see the microdata. But if you, for example, go here and look at the source code, you see here in the source code all the macrodata that is part of exactly this HTML page. Okay, let's go back to that. I simply copy this into the buffer and we continue to the next page. The nice thing about microdata is that Google, for example, provides a lot of testing tools where you can see what kind of structured data really is hidden in that page. Because search engines like Google, they are reading and make use of this structured data. Here I have a link to a structured data testing tool at Google Webmaster. Simply click on it. Then again, the browser pops up, and here you can give the URL of the HTML page that we have just seen, and I say run test, and you see here the HTML code with all the microdata in it, and this is the structured data that has been extracted from this HTML page. You see here we have a type, which is person, we have a name, which is then a character string, the name of the person, we have a title, affiliation, and so on and so on. So this is extraction of structured data, of structured microdata from an HTML file. You should try this out, definitely at home. Okay, let's continue to the most prominent microdata vocabulary. And the most prominent vocabulary is, I've already told you, schema.org. Schema.org is a vocabulary which has been started once on an initiative of Bing, Google, and Yahoo, so which were in 2011 the major search engines. This is now about 5 years ago. And the goal, of course, was to create some kind of semantic markup for web pages based on proprietary HTML microdata schemata. So they did not confirm to agree to RDF, but they are using nevertheless schema.org. And for schema.org, it's a microdata format, of course, then the meaning of all the vocabulary terms that are used is given in a natural language text, so the developers have to read it, to understand it, and the tools they are using, they have to process the extracted structured data in exactly that way. Who is using HTML file microdata schema.org? Search engines, of course, web crawlers, and also browsers can recognize it and understand it. So there's a small number of formats available, it's extensible, and of course you can map all this schema.org data also to RDF. This is not a problem. What are search engines doing with schema.org? They are creating so-called rich snippets out of it. So what's a snippet? You know this, in a search engine, usually if you are looking for something, you see a result list. And to understand what the found result is on or what is about, there are so-called snippets. Snippets are nothing else than a few lines of text that appear under every search result, and usually they should give the user a sense of what the web page is about and why it's relevant to the query of the user. Rich snippets then contain more. So they enable the search results to contain also structured data from the web page that has been found. So for example, you can provide the price of a book, the availability of a book and stuff like that. You can provide pictures, and the search engine is able to read this structured data, to understand the structured data if it's written in schema.org, and create a rich snippet in the search result, which is quite nice. And of course, if you look at it from an e-commerce or competitive point of view, somebody who is displaying more information about the goods he or she is selling is, of course, or this is a benefit if something like this is displayed. So therefore, you should use exactly these things to create rich snippets for your search results. So this is only a hint for that. Is it used, or how is it used? 5 years ago, it has been introduced, and you can say about 26.3% of all HTML pages, according to a study which has been performed in October 2014, they are using structured data. How do they come up with the data like that? So there is something which every researcher can access. It's the so-called Web Common Crawl. It's a corpus which consists of 2.3 billion HTML pages, which have been crawled, and all these web pages, they have been parsed, and they found out that about nearly 600 million of these pages, they contained either RDFa, microformat, microdata, and so on. This was not the only study. There is a little bit older study which says 30% of all HTML pages contain structured data, and this was a study made by Yahoo Research in January 2012, so even longer ago, and they used an even larger corpus from the Bing crawl corpus. So they used 3.2 billion HTML pages, and they found about that 1 billion or 973 million pages contained this microdata. That's not so bad. Another interesting study says that if you look at the top K Alexa websites, so these are the most popular, the top K popular websites in the world, and of course what these people did, they looked in the common crawl that they have, and you see here, this is the first column or the second column, you see here how much of these top 100, top 1000, top 10K, how much of them are available in the common crawl. So we start with 99, and the percentage of course gets lower in the end. From the first million websites from Alexa, there are in the common crawl only 734,000, but nevertheless they can be analyzed. And if you look at that, of course, in the top K100, you have an overall percentage of structured data of almost 75%, which could lead, of course, to the assumption that using structured data pays off in some sense. So you see the usage of structured data, if you go towards the million, of course, becomes less. It's quite clear because not every web page is really making use or investing the effort or had already the chance to include structured data. But nevertheless, including structured data into your web page is always a good choice because you benefit from it, because the search result in the end will be or will contain more information. And therefore, if you are, let's say, if you want to be found, just use microdata, just use RDFa, just use microformat, simply because then people will find your website. Okay, we have talked a lot about RDF and RDFa in this section. You have heard that we are using some kind of linked data vocabularies, which are nothing else but kind of ontologies or based on ontologies. And what we will do in the next lecture is we will talk about these linked data vocabularies, what they contain, where they can be found, how they are published, and how they are created. And the basic building block, of course, of these vocabularies is RDF and RDFs. And since RDFs only has a rather limited semantic expressivity, we will also look at the next stage of modeling, which is then the web ontology language.